Hi guys, welcome to another code film. In this code film, we're going to look at the executor services. We've already talked about concurrency in a previous video. There's an airplane flying over my room, over my house, so that's why there's some noise in the background. Right, so we've already looked about concurrency in the first video, where we looked at an application that we built using a simple understanding with threads. So in this code film, I want us to look at an API or a framework or a library that has been provided by Java to help us handle concurrency or multi-threading. Yeah, so let's just get into the video. So there are some terms that you have to become familiar with, or it should be something that's part of us when we are talking about concurrency. Process, thread, task, pools, synchronous, asynchronous, and execution order. Process, when you talk about a process consists of one or more threads. And let's go into our computer, for instance, and let's use task manager. For instance, task manager will show you all the processes on your system that are active, and those are background processes. Those two are not background processes. And you realize that the processes that we are seeing are applications, source code. So we have Eclipse, PDF reader, sticky notes, WebEx. All these are applications, and it has been tagged as processes. If we swing over to the details section, you actually get to see the process identification number, the PIDs that have been assigned to all these processes that are running our system. So what we are saying is that in that application, it can consist of one or more threads, and it's all performing activities. So if you are not conversant with this, you can also use the command line. There's always a terminal. You know why the terminal was made. It's just a textual way of accessing your application. So you type /, you get all your processes that are running on your system. You see all the application. Here it says it calls it as image name. You have PID, session name, session number, and memory usage. Image name is application, but it's an executable. Alright, so that's just for you to know that processes can consist of one or more tasks, and a process is an application or a service. Okay, now let's understand the thread part of it. So the thread contains a unit of work, and that unit of work is the task. So the process or the application or the service can have a single thread or more threads, and those threads are all work that is going to be done inside the application. So if you pick a browser application, the browser application can have one or more threads, and each thread is supposed to do one thing: do request and get responses, hit a request and get a response. Wow. So let's go to a browser. I'll open it in incognito window. So if I hit this is my first tab. This is my application. Let's look at it. Let's check it out on task manager. So I sometimes forget myself that I'm on the Windows machine. And you do realize that Chrome is showing here as an application, and then the various processes that are going on in the background. Sometimes I can't see. There's only one tab that is open, but why am I seeing all this? There are some other things going on in the background. So just follow. If I start a new tab, I'm hitting a new process. If I had a new tab, I'm hitting a new process. If I hit a new tab, I'm hitting a new process, a new process, and a new process. And the process can consist of one or more threads. So each of these can be considered as a process. Each of these can be considered as a process. In the context of the browser application, please understand that you could also have understood it as a thread, a new thread, a new thread, a new thread. But each thread has a purpose, and that purpose is that I make a request to a certain application. So I make a request to a certain application or a certain web resource, YouTube, and in my request I get a response. So that's the understanding I have for this. That's the understanding we are drawing from concurrency and process and thread. So for each tab that I hit, I do get my response. If you don't believe so strongly with this, then Chrome as an application has a tool that helps you to check all your tasks that are running. So you realize that it sees this as a process with a process ID. So you can end that process. Let's end this process. And realize that it's gone. You understand? We've killed the process. And that process was to do a task, and that task was assigned to get a request and response from the browser. So from the web resource YouTube. So please let's get the understanding again. A process can consist of one or more threads. Just understand that a process could be a service, it could be an application. Just understand a thread has the work that has to be done. The task is the work being done. Pools are the number of threads you want to have, or the number of objects you want to see in concurrency. So if you have items that you've labeled, I want to see all the 5 items happening together at the same time. That's the concurrency. So you determine the number of pools you want. It could be fixed, it could be stochastic as and when it occurs, or it could be a single thread. We also have synchronous and asynchronous. Synchronous, just understand that synchronous means I hit a request when the response is ready. I hit a request and I get a response. Synchronous, hit a request, get a response. It's almost instant or immediately. Asynchronous is I send my request, I give you an order, then you prepare the food, then you bring it to me later on, or as and when it's ready. But with the synchronous, I go to the drive-by or drive-in. I tell them that I want a cup of coffee with a burger. It's just ready. It just gets this to me. But if I go to a different restaurant, or if I go to a restaurant, not a drive-in, but a restaurant rider, I tell the restaurant that I want this food, and the restaurant tells me that it will take me 5 minutes or something. So they are now going to prepare the food. So they just tell me that your order is in queue or is pending or is not yet ready. When it's ready to be served to you. So that's the synchronous. Synchronous is request response, or I give my instructions, I get my response instantly or immediately. Asynchronous is I give my instruction, my response to the instruction comes later on, but I'll do get a response, but the response I'll get is not the expected response. It's a response for you to just have to know that it's been looked at. Okay, and now the last one I want to understand is execution order. Execution order just tells you that all your threads that you have, there's an order that defines how your thread may or may not run. The order of thread running is not really you can't determine that, but when it comes to using them, the tags that you have, it can, there's something that can occur. So just have these things in your mind. It's not more of, I don't want to stress more on what they do, but more of the terms: process, thread, tags, pools, synchronous, asynchronous, and execution order. Just have them in your mind. Just let them settle in your mind. So let's go straight to the film, but before that I want us to look at the methods that this API or framework has for us. Some of the methods: invoke, any, invoke, or execute and submit. Invoke, any, invoke, or execute and submit all have a method you have your operational style or operational behavior. The behavior of execute and submit is more of asynchronous. Invoke all is also of, so execute and submit are more of asynchronous. Yes, correctly said. Invoke all is more of synchronous, and invoke any two is more of asynchronous. Yeah. So invoke any, execute and submit, asynchronous behavior. Invoke all is synchronous. So just have in the back of your mind that invoke any, execute and submit, they lean towards more of asynchronous behavior, and invoke all leans towards synchronous behavior. Okay, so let's go straight to our box, our IDE, and let's do some work. I'm just introducing the framework. This is not a rigid code framework like the other one. This is just introducing the framework. So I'll create a new project and I'll just run you through some hacks that the IDE has for us. So group ID com.CodeFilms, and I'll call this simple executor service demo. Executor service app, or simple executor service. The artifact ID is like the project name or the service name. Don't worry about the name, don't worry about all this. Let's just go straight. There are our states. So we have our structure, our Maven structure. Let's give it some time. It's still building, or it's still scaffolding. Sorry. So we have. We'll look at all this later on. There's a code form I'm going to release on the application structure, or the application's architecture with regards to the software and the projects. We'll look at that later. So we'll first create a new class. I'll call this class. I'll create our class in our package. So let's have a package first. Or you can still have a new class. In creating a class, we create the package. That one too is also there. I did this now. Alright, so our packaging will become the CodeFilms.executor service. Let's just keep it simple like this for now. Then we call the app demo app. We'll have main. So our application is, our class is getting ready. The IDE is doing this work. Okay. Alright, so there are some functionalities that the IDE provides for us that makes our work, that helps us be very productive. And because of the direction we are looking at now, using a library to do the work, I want us to first of all do an overview of some of these IDE productive tools or productive features. If you see on the top here, I have something showing my project or my artifact ID, where I am now. That's the particular directory, the package I am in, and the class I am inside. And then it goes on to tell me the method. Okay, so this is actually something that will help you later on when it comes to when you start getting some type of workload. For now, just know that this exists. Let me hide the breadcrumbs. So it's not easy by default, it doesn't show. So I'm now going to start using these features for this video. Okay, so let's just start with our video, and I'll be showing you the features gradually instead of me just holding an overview. I'll let the features be coming gradually, so we see why we need them and why some people thought about it. So the first thing we want to do is, how do we use executor services? First of all, let's check our Java version that we have on our machine. For my small knowledge, what I know that my machine uses Java, 2 versions of Java, and I'm going to check that by doing an echo home. What I have installed is a Java home is Java 9, but my Java runtime system is not within Java 9. If I do Java C, Java version, it's within an open JDK of 16. That's Java 16. And so I want to change this. I don't want this. I don't want this to be running in my project. So I'd rather change the build path, configure build path. And let's do the changes here. Don't worry about this. You should worry more about what you are going to do. Let's use Java 9. I don't have Java 8 installed, so. And let's show this in terminal and see what's up. So that's the Java version that it knows. But what I'm using is not this, is actually Java 9. Oh, cool. Let's show this terminal. I want to get bash terminal. So this is what is on my system, and there's another Java version. That Java version is coming from an old installation. I want to just prove. Sometimes this is when you're doing it and people you don't see it, people don't believe. So it's coming from an installation of this part. So yeah, let's just check it out. It's in the download, so it's coming from Eclipse. Came with the Java version, and that's what it looks like it's working with. Alright, but when we do our echo home, when we go and check it at our system environment variables, we realize that we don't have, we are using this, what we have configured, and that's JDK 9. So if I go to a system environment and check Java home, this is the Java home installation I have, JDK 9, and that's what we are using for our projects too as well, because we've done the configuration there. So if you still don't doubt, I'm just showing you that these things are there. You can also check the install GREs. So we have two. We have JDK 9 and we have the default, and that's the, it seems to come from Eclipse from what I'm seeing here. So hope we are fine now. So we are using what we installed, GRE or JDK 9. We are not using, we are going to switch to that one. We are no longer going to use the web, what Eclipse bought. So build path, configure build path, edit, JDK 9, fine. accountable now. Okay, so now let's just go straight to our executor services. So I want to access, now we are getting to it, because we are going to use a library to work. You want to be able to make some quick inferences into the library without going too much on the internet. You want to prevent something like this, whereby I know that executor services has a class called executors, and that class is what will have the methods or utility methods to create the threads for us. And it's a library. Remember, it's a library. It's a library from Java, and it's in the YouTube package, and it's about concurrency. It's about concurrency. So Java, YouTube, concurrency. So it's coming from Java. It's not coming from me. It was coming from me to have been signed with my company ID com.CodeFilms, but it's because it's not coming from me, it's coming from Java. That's how so that's the package name. So I do executor of this. See, I want to prevent going on too much into the internet to search for something like that. I have to search for, I have to go and do a Google search for executor service or executors Java. I want to prevent something like this. I don't want this to be happening all the time. Executors in Java, come and read the documentation or the API specification to get what I want. So I have to now go here, click on this, and read online. That's what I'm trying to prevent. So because I want to prevent that, Java or the IDE, Java has a way for you to read about the framework you are using as when you are using it. And also the IDE that I'm using, Eclipse IDE, has some features that helps you to easily navigate through the library, the API, and find what you want. So first thing is Javadoc. You want to show something called Javadoc. And the reason you want to show that Javadoc is that Javadoc is the documentation for an API you're about to use in Java. So if I put my Java on executors, it tells me what executors does. As simple as that. I don't have to go online. So just understand that in Eclipse is window, show view, and other. You find what you want here. Fine. This is just to read before implementation. Now what if I also want to know all the methods, all the classes, all the objects available in that executors class? It could be the class hierarchy, it could be the inheritance structure, it could be the how polymorphism is being used, inheritance, how encapsulation is being handled. You want to see all that. You understand? You're a developer, so you just have that understanding. In Eclipse, what you can do is that you can right click, and we have two ways of doing that. We have the quick open type hierarchy, and also have the quick outline. The open type hierarchy will actually give you the objects, the class subject, and its associations in terms of inheritance, whether it's an object or it's like an object, is it or is not. And those who have OOP concept to understand what I'm saying. And here are all the classes that belongs to this, all the members that belongs to this class executors, and it extends from Java object. So if I click on this, it gives you all the available methods that you can use, or the members that belong to this class. So this is one way. Another way of checking this out outside using the type hierarchy is to use a quick outline. So if you want to use a quick outline, I think is show view, quick outline. Yeah, so the outline view. So outline will outline all the objects for you when you are working. So quick open type hierarchy is fine, but quick outline also shows you the method. So if you look at this, we are in this class, we are in this package, we have the class and we have the method. This just tells you what you need to know for that particular class or that object. And the outline is more of showing you the members belonging to that class. They are almost the same, but they are not the same. We don't see the type here, type hierarchy here, no, but we are seeing that here. Okay, if you want to make clear, when I do go into this class, executors, let's just type, I know I'll create a number of threads, so let's say 5 threads. I'll create like 5 threads here. Don't worry too much about this. So 5 threads, this is what I'm going to create. If I step into this, I want to get more information. Voila. When I come to my quick outline, you see quick outline shows me almost everything or that I'm seeing in the type hierarchy, but I don't see the type in any type inheritance flow. I'm just seeing all the listed classes as and when I click them on my project. So I'm now inside the class and I'm actually checking out the members or the methods in that class. Hope it's clear now. Yeah, so that's for quick outline for you. It comes in very handy, but this is more workable when you really need to know what you are doing. And when you click on it, your Java doc shows. You click on it, your Java doc shows. You click on it, your Java doc shows. You click on your Java doc shows. You click on your Java doc shows. Okay. So now let's look at a simple. Let's have our concept in mind and let's flow. So new fixed thread pool. If say we want to create 5 threads, so we are going to have 5 threads. That's what we are seeing here. It's fixed, and these 5 threads are all going to do some work. So we are getting to the tax because the thread handles tax, and a tax is a unit of work that has to be done. So how do we now access the methods that will do the work? Because we are using an API, and those methods are in another implementation. That implementation is the ExecutorService implementation or interface. That's the contract. So how do I know? Just look at it. If you look at the documentation, you see that it returns of type ExecutorService. So if you just know a little basic Java, you just know the ExecutorService. It's an interface. You just do ES. Just keep it simple. Okay, so this is fine now. So ES is new. It's going to help us have access to all the methods we need. So ES dot, and you see all the methods here being listed here in our quick outline, in our view here. It's a list. So we are fine. Okay. So that's 5 threads for us. Now let's start going into the methods. So let's have a problem, a simple problem. In this application, you want to do something. When the application starts, you want to display text that is started. When it ends, you want to display text that is ended. And when it's doing its own concurrency bit of it, you want it to do its own concurrency in its own way. You understand? What I'm trying to say is that we are splitting the application so that we have something that shows the view, we have another thing that shows the ending, we have another thing that shows that does the work. Someone will say you can actually redesign this to do it wholly multi-threaded, but we are starting small. So let's have a method now. This method will just say start. Application started. Those of you who are familiar with Java, then you can use a logger to do this. So private static logger. Let's make it final. You use a Java logger to do this. This class. I'm looking for this logger. There's a default logger in Java. How to use this just to move faster. Okay, then this is how we do. I'll do logger. I'm trying to hack it. Okay, what I got. So let's give the type logger. Don't give the typo. I do notice logger. Code. So which logger are we going to use? We'll use a Java util logger. Okay. And the Java util logger, we'll just open type hierarchy. Sweet. Get all our methods here. And we have our nice Java doc here, so we know what we are doing before we start. Yeah, so logger will just use to log messages, and we can, how do we get our logger for this? So we have logger get logger. Someone say, how do I know? And some of these things I've been using them. If not for that, I'll have to read about it. That's the honest truth. Or you could have just on what you see, you can click on it and open the class and see if there are any sample examples for you or anything. But if not, you have to go online or read or know how to use it before. But because I've been using some at work in here too, it's quite straightforward for me. I know what to do. Yeah, I know what to do. So get logger. Then the name will just be there. It has to be a string. This one has to be a string. Let's see, there's one too that has string. There's so many representations. And that closed to string. Okay, so sorry, I'm going to that. Let's move on. So let's use the logger to do that. So rather use a logger here. Extract it as a method. New factor. Extract method. Show application. We call this method show application. Start text. And it tells you the access modifier. Some of these things are not really my focus. That's why I'm moving a little bit faster. I'm using most of the IDE to do the work. So I'm using the IDE to extract the method and get what we want. So it will be private and static. The signatures are there. So this will be how it will start. Then you also have one for when it ends, show application. We'll use the logger info. And we'll extract this to as a method. So we are looking at the extraction again. So it's refactor. Sorry. Then we just do extract. So where is the extract now? Okay. Let's comment the error out. Refactor. Extract method. Now we call this show application. So the method name, the access modifier, and then if it has any runtime exceptions, and then the preview of the method signature. So it's private and static. So private, static, void. It's static because we are calling it inside the static class, static method. So source format. So we're just keeping things tidy. So when it starts, application ended. When it starts, application started. When it ends, application ended. So let's just run this without starting our executor service. Let's look at the application flow, or the flow for this application. And Java application. When was the Java application? So it tells the application started and application ended. So this is beautiful. We are seeing everything as we want. That's fine. And it's being logged. Now that's the default flow now, but there's no concurrency happening right now. So right now, let's have a simple object. We're going to have a cat. We're going to create a cat object, and that cat object will have some record. We'll have a record that defines the cat, and we'll have a number of threads to show the records of the cat. That's just concurrency. So we are just going to display the cat's records that we have, but we don't want to use a loop to do that. We want to use we want the executor service to do that for us. So let's just get into the video to understand what we are doing. So let's now start using the executor service. We have 5 threads. So what we are saying is that we have 5 threads. So we need 5 units of work. 5 separate units of work. Within the same thing, you can also make them do separate things. It's all your creativity. And let's create our cat class. Now let's show why we need our breadcrumb. So I'll do show breadcrumb. So if I'm in breadcrumb, I can easily navigate to any package I need when I have an object there. So I can easily navigate to any package, any class to do what I want to do. That's why I need the breadcrumbs. So we are going to get there as to practical examples. So I'm not going to create a new package of a sub of the same base package, and I'm going to call this one objects. And this object, I'm going to create a cat class. That's the name of the class. That's the noun. And in that cat class, we are going to have. So you see that from now in the. So if I come back to my demo app, you see my flow says in this main I have 2 packages. If I tap into this, I move straight to the cat class. That's the breadcrumbs. If I tap into this package too. I'm moving to the demo app. So that's the beauty of it. Gradually. So in this cat class, I can define members, and each member will have its own visibility. All cats are supposed to be private. The name of the cat belongs to the cat, encapsulated. Then the age of the cat also be encapsulated. You can make it an integer. So be encapsulated. Then the cat ID too. Make it an integer. And then also the name is ID, and let's say it's sex or gender. Now you can make it a character. Gender. So realize that as I define my methods, my members for the class, in outline I'm seeing each one of them, and it's type. That's for the outline. But if I'm to use an open type hierarchy, if there's a type hierarchy that relates to this class, is supposed to show. So there's nothing really, I'm not really doing any complicated thing. I'm not extending or inheriting anything. So just for you to see the beauty of some of these features. And you can see that they are all red because they are all private. They are all private by default, and the reason this sign means they are not being used. So it's not being used, that's what it means. So if I do something like this, if I change the visibility, make it protected, and just give it, let's just do it, and so that the visibility of this changes to, it shows you a different color. Put that, let's just have that. If I move the protected, its visibility also changes to a different color, blue. So this is more of package private, the package private behavior. I cannot access this object and in demo app if it's in a different, if it's in a different package. If I'm in, let's refresh this. The structure is not looking good. Alright, nice. So I mean, don't let us use the project Explorer. Let's use the breadcrumbs. So I mean, I have two packages now. If I'm in cat and I go to this package, I can't access the object N. And let's just go into that. So I do cat. Then I just say do cat. But I don't see N. You understand? Even though I haven't really defined its behavior, I can't access N. You get it? So it's telling you that this N is not visible because I'm in a different package. But if I had another package in ExecutorService object, another class in this object, another class in this object, I move, let's create another class, test. Moving fast, I'm sorry. Public static void. If I come to this package, and because this class is also in the same package as the test app, I'll be able to access N over here. That's the package private behavior. You get it? So now I can access it here and don't have any issues. If I do print it out, it will show something. let's swing straight to that. Yeah, other ways of swinging, you can also use this to swing. Test up. Simple. You are seeing the one. I'm accessing here, so that's package private behavior. Alright, so now why am I showing you all these things? So it's just for us to warm up. So it's coming. Now we know why we use the breadcrumbs. You can actually see it now. Alright, so now let's go back to our executor services. And now let's start with some keynotes. We tell that we want to have a cat, and that cat is supposed to have certain objects or records. And we are going to define an executor service to just display the cat's name for us, to display the cat's record for us. So if we have like 100 cats, we want to use concurrency to handle all those 100 cats to get their names. If you have 1 million subscribers, you want to use concurrency to be able to access the 1 million subscribers so that you can process their records and do whatever necessary work that has to be done on their records. You understand what I'm saying? So that's the concurrency bit. It's gradually coming. It's gradually coming. So let's have our toString, because you know that in Java toString helps you to know that it's more of what the object does, or the object. I'll say it's like the object's signature. It tells you about the object, it gives you information about the object. So if we do our toString, it will give us the name of the cat, the age, the ID, and the gender. Everything you need to know about the cat. Alright, so let's see this step by step. You can see it also in our outline. Let's do our test up now. Test up. You can actually just delete the class. If you don't like this way of doing, you can also go by the terminal. In the terminal, you can try rf. Let's do list first. Let's see this here. List cd, list cd java, list cd. It's quite lengthy, but I know some people want to be free geeks, so they always want to do things differently. If you think it's taking too long, you can just pipe through it and do show in local terminal bash. That's another way to. It will lift that command. It lifts the path. Let me show you something. Properties. It lifts this path and does the CD for you. So in my mind, that command is doing CD and the whole path for you. It could be this, it could be that. So just that's the trick. So that's what the tool does. When you do that, God, some people are saying, how do you know? Like, if you don't believe, let's just try something again. So I have CD here. So CD, then let's have a list first. List. This mean so CD, then documents, and then the path, and it keeps going on. So you can actually see for yourself now. So if I just do this, properties. So let's go with this. And this one we're in a git bash terminal. We are not in a Windows. It's not like a Windows terminal. So you have the same behavior. You get it? If not, let's try the other part. The other part is actually the part. That's part definition. Just like the Windows. Yeah, so no such file. let's go back to the table first. Right, so let's go. Yeah, so no search file. It's not really, it doesn't understand this. But there's no C drive, nothing. So right, is this part right using? Another video, look at path and file streams and the path objects and all those things. Those ones are a little bit advanced, so I mean sometimes I get lost. Alright, so let's just delete the class. Let's just go back to what we did initially and delete the class from the geeks among us. So let's just do rm minus rf test app .java. Do a list again. It's not there. Fine. Let's refresh. It's gone. So the geeks among us, this is what the terminal does. Instead of using a GUI, it increases your productivity. There's no doubt about that. So now let's get straight to the methods. So realize that we've looked at how we're going to do our concurrency. So we just want to call the methods that we need. Let's have our type hierarchy defined for executor service. Open type hierarchy. Yes, so the methods that we've made mention in our slides: invoke and invoke, or execute and submit. We're going to start with submit and execute, then we look at invoke and invoke call. We just want to have a feel of the executor services framework that's coming from being provided to us by Java util, the Java util concurrency package. We just want to have a feel of it, just a feel. So first, let's start with execute. So execute. So even showing here. Yes, dot execute. Oh, okay, executor. So that one has a different executor. So let's use executor. So I'm not seeing execute yet. So how are you calling execute? If you are not okay with this, open it as a quick outline here. It's going to show the context. I want to open it as an outline rather. So let's do an outline. Executor service. Let me just do the outline. Yeah, so I have it here. And then extends executor. So you now actually see the flow. Extends executor. So you can actually find where that executor is coming from. You can also step into this. I don't see execute here, so let's go into this to open type hierarchy. So you now know where execute is coming from. Execute is coming from another interface, and because the interface extends it is inside the Java inheritance structure. Yeah, so that's where it's coming from. If not, let's see, open core hierarchy to show also work. Open core hierarchy. Yeah. Open core hierarchy. Yeah, so don't worry about this. We'll look at all these things later. When we call methods later, we'll call, if for instance we use it here, that one we understand. Open core hierarchy, that one we understand that it's being called in main. Yeah, so later on we look at some of these things. So execute, from what I said, let's look at Java doc. It's asynchronous. It's mostly asynchronous. So execute a given command at some time in the future. So when it's ready, it will give it a response. So we're going to define the tags. Remember we said that threads, tags, and process. So the tags is runnable, and runnable is just going to say something. So we're going to say sayable. Runnable, sayable, interface definitions is all from Java. I'm not the one who wrote it. So there's a convention that you have to use when you want to work with the interface, but all these things, they come later on. They'll come later on. So I'm writing this as a lambda, but not as a lambda. I'm just going to define what to do over here in the runnable. In the runnable, I'm just going to say sysout hi. I'm just going to say hi, and I'm going to pass that runnable object here. Sorry, if not, I'll just type it out. It works perfectly. So you look at our Java doc, it tells you that execute. The method signature says it needs an object, a command that's nice, of type runnable. So we've just done this using an interface definition. If you are not okay with this, you can also use a lambda definition. A lambda definition for this, let's pick the same runnable. And let's do runnable 2. And this time around, we won't use the lambda definition. We won't use the anonymous class definition type. We're rather going to use this one to do the work. And how do we know? We are actually overriding it in real time. So run takes no argument. It just takes no argument, but it has a body of work. And the body of work is what we are writing here. So that's the body of work we just handled. Say my name. Yes. So say my name is. So that's what we've just done. We've just defined this here. If I do pass say runnable to this too, so I have 2 services I'm going to execute separately. The fact that I'm using one tag doesn't mean I can't use execute again. Execute is a method, I can call it anytime. So this will execute, this will execute. So it doesn't spoil anything. So let's start our application and look at the behavior. If you don't terminate the framework from running, you are not going to get the expected output that you want. So application started, hi, say my name, then application ended. Let's run this again. Five threads. Let's run this again. Okay, so you see that the behavior is changing now. Say my name is coming first, then hi. So it will always change because of the number of threads. Hi. Let's use one thread now. So one thread. And let's see the behavior. Good. Now our behavior changes. So you have one thread that is supposed to go and do this job and also do this job. You understand? So let's run it again. Say my name. Let's run it again. Say my name. This time it's fixed. Let's run it again. Say my name. Okay. Let's run it again. Say my name. Okay. Now it looks like, but it's not safe. Don't believe it. It's not safe at all because anything can happen. So just by the way, so if we increase our tax, let's increase our tax again and see the behavior. So let's increase the workload of the thread. See my name thread. Let's keep doing that. We are passing more work to one thread, which is being done asynchronously. Let's run it again. Say my name. Let's run it again. Say my name. So one thread. Okay. Let's, we'll have to keep increasing the workload. Say my name. Say my name. Let's just do 5. Sorry. We'll be okay with every assertion that we make. behavior is changing. Right now, see, it's still not safe. So it's all not safe. Yeah. So it's still not safe. So we can now bear for ourselves that it's not safe. It will change. The behavior does change. So you don't want to go with such an approach. Look at all this behavior, you understand? So the workload, when the workload increases, the pool is still 1. You are still struggling. If you make it 70, no, 70 is too much. It has a relationship with the number of processors you have on your PC and whether it's quad core or not. This is not a multi-threaded class, so you see when the pools increase, it's all asynchronous, you see, so it does any one of them and it's ready to return the response because our pools have increased. That's a wrap for execute. So execute is asynchronous, so I've seen the relationship between the pools and the threads. I like what is happening here. Okay, now I said something that if you have a long running task, let's take one for example. The thread hasn't yet, the thread is live because it's a simple statement. We are using a framework and concurrency is happening at the background like in an abstraction. Let's say like in an abstraction. But look here. This is like an independent worker occurring in main, of our demo app, our process. I'm using something to do that work, but I'm not seeing my execution being carried out. I don't know if my execution is being carried out or not, whether it has ended or not. That's what I'm trying to say, whether it has ended or not. So if I do create a for loop here, for a loop that runs forever, I'll do this out, running always. I'm expecting my application to crash because I'm expecting a behavior whereby the application hangs because this is always going to run. This is a task, it's always going to run, and I'm using a framework to do that work. Or I don't want to call the ExecutorService an application at this point, but I'm using a service to do this execution, to factor in the concurrency. You understand what I'm saying? To factor in the concurrency out of its normal flow of show application text and show application and text logical arrangement or procedural arrangement. So there's a command or there's a method that allows you to shut this down. You see, it's always running. But if you look at, let's stop this for now. But if we go up to our flow, it ran for so long. No. Because we ran for so long, we can't actually see the start and end of this. Let's just run it again. So it does the flow. So, and this behavior application is behaving. It's not behaving in a functional or procedural way of working. It's just running all the time because of this bug that has been inserted into the application or this virus. So we want to shut this down. We want to shut it down. So we look at the other method of shutting down. We want to shut this down when it's done with its concurrent operational, its parallel way of doing its work, of handling the work that we've assigned to it. So let's run this application again. And with this new method that we've introduced, the shutdown, we want this service to shut down, this application to shut down when it's down doing its work. You understand? So it's still running always. So we still have a problem. If I comment this thing out, let's comment the bug out. let's do the shutdown. The shutdown operation shuts down your threads for you. It does it. It has ended. It shuts it down for you. So that you don't have that behavior, but that behavior still exists. So that behavior still exists. Someone asked me, how do we handle this? We also have another method called await termination. It tells us how long to wait before we actually shut the whole system down. So I'm going to give myself 5 seconds. I won't give it too much time. 8 seconds. I'll give myself just 5 seconds. After 5 seconds, whether the process is ready or not, it should shut down. That's what it means. Actually, you should now handle it exceptionally. Await termination, then we shut down. So run. Wow. Our bug is infected because the loop is running forever. There's another method you can use the shutdown now too. Shutdown now. So this bug is going to be a problem because the for loop is always going to run. So it's going to run. So how do we handle this? So let's just comment all this out and let's check. Let's even check this. Let's check this. Let's check the Java doc and see what it returns. To return a boolean, so let's see if it is true that it's shut down. I want to define a behavior for it. Let's log it. True. It was shut down. Application. We'll try application test later on. You don't want to change it too much. We just want to check this first. Well, just one way of just fixing this. The loop is always going to run. So let's give it a range now. Let's do this now. So no, okay, that's good. To print something out. Okay. So what we've done now is that we are printing to a certain limit, and we want to see how we use the awaiting termination shutdown to do this work. The forever loop is sucked inside the process. Even if we shut it down, it's still hanged inside the process. Wow. Okay. So await termination block all tasks have completed after a shutdown request or time and concurrent transmission. So we're giving it, let's make it just 1 second now. Let's just do 1 second. And let's look at where we are. We are in true. And we shut down. And let me check if the boolean returns true or false. True if executor has terminated, and false before termination. Okay, so we are in true. So it's rather this way. So rather this way. So it's supposed to come after the shutdown request. So shutdown, await termination. You are in true. So it will wait for 1 second before this kicks in. So let's go. Let's see. Let's do fixing our back with the behavior like that. I'm shutting down the whole framework. It's very weird. Weird behavior. Later how to investigate that. So if you want to shut down. So shutdown will just shut it down for you. And we've seen how it behaves when we have a for loop. And await termination will wait for some time. Sometimes when you do the shutdown, you may not be ready to shut down as and when it is stipulated, because it's still doing something. So we wait for a while. So this is how we wait for like 5 seconds before we shut down. So let's do it for 1 second. We've initiated the shutdown request, alright. Let's have a record that goes all the way to 1000 or 100. Running no waits plus I. So it's going all the way to 100, but we say shutdown. We say shutdown. We say await termination. So that's why I need my Java doc to be able to read, to know what the methods do before I start calling them. So even though this method does not wait for previous tasks to complete until you use await termination to do that. It initiates an orderly shutdown in which previously submitted tasks are executed, but no new tasks will be accepted. So my order, I've defined my work, and this one is going all the way to 100, and I'm calling it to shut down. To initiate an orderly shutdown, to initiate it in an orderly manner. By the last one is going to run for 1000. So await termination says that you said shut down, so it's going to shut all the threads the web that is doing. And await termination says let's wait for like 1 second and we'll see if it has been successful. Then we see that we've shut down everything. So it will block all the tasks that have completed execution after a shutdown request. It blocks until all tasks have completed execution after a shutdown request or the timeout what occurs. If we run this now, it's just 1 second, and now I'm going all the way to 100. So you have to shut down after waiting for 1 second. Wow, it happens so fast. Okay, let's move to let's increase it 1000 or more than 1000. So it's still waiting. It waits for everything to occur first. So there's the whole process is running independent of the application. So we have our shutdown to shut everything down, and it will wait for a number of just from the Java doc to blocks until all tasks have completed execution after a shutdown request, blocks until all tasks. So it's going to wait for all the tasks to run before it kicks down its work. It does its work. So it's just a way of managing the threads to make sure that each one is being executed in the right manner. So that is a shutdown. If you don't have the shutdown, the application will not shut down. The application will not shut down. The for loop is a bug. Down to the shutdown has to be able to do that request. How to investigate this thing. Let's clean all this. I know I'm going to commit the product. And that the application it won't stop It hasn't been shut down, it's still running. I'm trying to find a use case. I'm trying to do that live. But if you keep running this, oh gosh, yeah, save. Let's go up. Let me reduce the count to 100. Yeah. So it doesn't. The order is not really being defined here. The application ended tags has come on top of the full logical flow. So the shutdown and the await termination will keep it constrained. So you set that shutdown, and it's going to shut down in an orderly manner. But let's wait for a while. Let's wait for everything. Let's wait for 5 seconds, and we keep everything in order. But as it stands now, there is no order. So it's like the application is still running. The shutdown is still live. To me, it's still active. It hasn't really been kicked off. It hasn't really been kicked off. So it's affecting our flow. This is not the flow we define for it. So our flow is that do all the work and later shut down. When you shut down, then print this. So that's the defined flow for it. But as to how the work is being done concurrently, we don't really bother about that. You understand? Whether this came or that came, it's changing. It does the concurrency bit because of the thread pools that we have. So yeah, so we're okay. Shut down, then await termination. Alright, so we're fine. See my name came, see my name, but hi is coming. So execute is asynchronous. Now let's look at the invoke in and the invoke all. So invoke in, as the name suggests, it will invoke any of the tags for you, any one of them, and invoke all of them for you. But invoke all do it synchronously. You to do it synchronously. So our cat, for instance, let's our cat. Let's call this method easy dot all. So the method signature says that invoke all. Let's go to the Java doc. Invoke all should be of a collection that extends a callable object. So the collection extends the callable object. That's why we have all this here. If I click on this, for instance, to help me to know what this is referring to, and it tells me more about the interface and stuff. But I know that this is the list interface. So the list interface implements this. So if you don't know this, you will struggle and all that. So we need to have it should be a list that extends a callable object. So that means if you are using a list, the list should have this behavior. So let me get it right. I want an example. So we are okay with all this work. That's being done. We are okay with this. And we are okay with this too. Discovery. So we invoke all. So let's have our list now. Let's look at this. If I do list dot cat, say cat list. Let's import this. Cat list dot add. And I'll add my cats here. So let's define our cats. let's go straight into our cat class. We really want to go by that way. Let's define our constructor. Let's have a Java log for this. It makes my work easier. Their own meals. You have a program now. See, list. Let's look at list. Open type hierarchy. List extends the collection interface. So, in the signature that they provided, we can use a list instead of a collection. By saying that in that list that you are passing, make sure that it extends a collabo. It has to be of type collabo. Anything passed has to be of type collabo. So our list we have here, our cat, the cat object we have, that's the E. The E that we are creating. It doesn't extend, the E doesn't extend a collabo tax. This E, it doesn't extend a collabo tax. So though this extends collection, the boundaries defined here says it has to be of type collabo. So to make this a collabo type, we can't pass this. So when we are passing, we are getting an exception. You get it? The method in roll call is not applicable for the argument of type list. You understand? List is a collection. There's no doubt about it because of inheritance and all the flows we've from Java. Lots of knowledge. So we are going to make this extend collabo. So implements collabo, and this collabo is a string. So when we do this now, realize that our cats can now be used for the work that its purpose has to serve. And what we return in this toString is in this call is the toString. So what we are just saying is that the cat, we are now considering the cat as a thread and that thread has a unit of work. That unit of work is the name that it will be printing out. That's the core. That's the core. So our cat now, for all the cats will be running, we are going to just bring the name from the core. Threads have a unit of work. So based on the application you want to build, you have to define what you call as a thread, or what to be the process, or what to be the task. That brings a lot of different concurrency solutions. So we invoke all catalysts. We're going to invoke all the objects here. It will do it in a sequential order, so it's synchronous. Not because it's sequential that is synchronous, but like to do it for you, like I'll give you the request to give you the response, and it returns a feature, a list of features. That's good. So we have to save that one to list feature of string, and we'll call this list. And what we'll do is that we'll go through the list, and we'll go through the list, and we'll get what we want from it. The future object that is holding our items for us. You can also check if it's actually done. If the processing is done, then you print it. If it's not done, then you print it. That behavior you define it, or you skip it or not. A whole lot of stuff. So this is just basics, nothing fancy. So if it's done, then you just print out. The object we had. So we are using invoke all. You look at execute. We are looking at invoke all. So invoke all run everything for you. So we start from 1, 2, 3, 4, 5 to invoke everything for you. And our thread pools is 10. So we have enough threads or enough workers to execute the task. And that task is the cat. Just bring the cat's name. So let's look at the behavior. We have no shutdown. Let's shut down. We don't want this thing to hang. Back to the normal process flow. So you can say it's executed just as I said. Alright. So if you can run it several times, the order won't change. For this, the order will never change, because it's invoke or to start with this, do that. That's how it's running. But we make it invoke any, and let's just do it. Let's do an invoke any. So this is for invoke all. Let's have an invoke any to this. It will invoke any one of them for you because you have enough threads. And now you can't pass a list. You have to pass a single object. I mean, you can't return a list. Sorry, we are returning just a single object. So I don't want to put my code, but it seems I have to just call it and do it that way. Let's make this. Let's refactor this. it will invoke any for you. So as it says invoke any, to invoke anything for you and throw it to you. So the trade pools are a lot, so it will pick any one of them and throw it to you. So that's the between invoke all and invoke any. So let's comment the invoke all. So it's now giving requirement and you are true. So it will terminate after the number of seconds stipulated. You know, you can wait for like 5 seconds and you realize that it's waiting for 5 seconds. Okay, so now it's giving you John. So it's going to invoke any for you. But if you reduce the trade pool to 1, the behavior changes. To execute only the first one for you. To always execute John for you. It will never change. Because the trade pool has changed. So it accepts the request. It accepts the request sequentially by executes it. It's executed asynchronously. So it's like that's a synchronous behavior when the trade pool is 1. When the trade pool increases, it behaves as it wants. So that's what the invoke any. So invoke all the, keep that in your mind as synchronous. Execute and submit are asynchronous. And invoke any will do anything for you. If you restrict the pool size to 1, the pool size is just 1. So it's only 1 thread or 1 worker that is going to do the work for you. So it's just that one will be doing the work for you all the time. So that's the cutoffs for you. I want to wrap with this video. We looked at invoke and invoke, or we looked at execute and submit and execute. There's no difference between submit and execute. Submit. So this submit for you. Passing a collarbone, passing a runnable, passing a collarbone, passing a runnable tax to you that execute. So if you don't appreciate the council, you go and read more. Subjects and volume return tax for execution returns a future representing the pending results of tax. So someone says, so when do I know what to use? Well, you just have to read. So literally some of these things you just have to read. Yeah, you just have to read to know which one you have. The command you execute in a new trade, in a pool trade, or it depends on what you want to do. So you want to read, but you have to just familiarize with this class. So upon successful completion, it executes 2000 its own. And so it all has, this one is based on the executor's implementation. Execute, we need to execute it, and the submit is more of getting the job done. So upon successful completion, yeah, so they're all asynchronous. So I think we are okay. So if it's upon successful completion, to return the task for you. So that's it for this CodeFilm. So that'll be it for this CodeFilm. And thank you guys for hanging around. I know there's a lot of work in this, but this is not the actual demonstration. It's just familiarization. Later on we'll do something nice and sweet with this understanding. Alright, bye.